Okay, so we've been doing a lot of scatter plots and talking a lot about the correlation between the data on the scatter plots. And so far, we've just been able to identify what type of correlation it has in words, like positive or negative, and more specifically, strong positive, strong negative, weak negative, or sometimes no correlation. Today we're going to be learning about the correlation coefficient, which is a numerical value that represents the correlation of the data. Okay, so we're no longer going to just say strong positive. We're going to give it a numerical value to represent how strong it is. Okay, so the first thing you need to know is a correlation is a relationship between two events where a change in one event implies a change in another event. Okay, kind of like yesterday we were discussing that example about the guy's website, and as the days changed, as the days increased, the number of visitors visiting his website also changed. They increased. Okay, we also talked about the example with the sandwich shop and how as hours increased, the sandwiches decreased. Okay, a correlation is a relationship where a change in one event implies a change in another. Now, that does not mean that a change in the first event caused a change in the other event. Okay, and we'll talk about what I mean by that after you write it down. Okay, correlation doesn't mean that a change in one event caused a change in the other event. Does the hours going by cause the sandwiches to sell? No, they just happened to sell as the day went on. But couldn't you have a shop that was selling sandwiches and they didn't sell any? Yes. Okay, time going by did not cause the sandwiches to sell. It has correlation, but not causation. An example of something with causation would be something like, as temperatures increase, the snow melts. I mean, that's direct causation. The snow is melting because the temperatures are warming up, right? That's what causation is. Okay, but causation is not that example yesterday with the sandwiches. The hours going by did not cause the sandwiches to sell. They just happened to sell in that time. All right, number 3. The strength of a linear correlation can be measured using a correlation coefficient. Okay, so like I was talking about, I've been asking y'all, like, what kind of correlation this has, what kind of correlation that has, and you would just say either strong positive or weak positive or strong negative, weak negative, or none. Today, you're going to be able to tell me a correlation coefficient, which is a numerical value that represents how strong or how weak, and positive or negative. Before determining this correlation coefficient, you look at the scatter plot and make an initial assessment of the strength of a linear relationship between the events. Okay, once you've written down that last word, you can flip to page 13. Okay, now, the correlation coefficient is a number that ranges between -1 and +1. You will never have a correlation coefficient outside of that range. It'll be a number somewhere between -1 and +1. Okay? A correlation coefficient of -1 indicates a strong negative correlation. Okay, so if -1 indicates strong negative, what does +1 indicate? Strong positive. Okay, now obviously, between -1 and 1, we have 0, and then a bunch of decimals between those two and decimal values between those two. A correlation of 0 indicates a very weak or no linear correlation at all. So like say you were looking at a scatter plot and the points were just all over and you couldn't figure out where you would even begin to draw your line of best fit. That means there's no linear correlation, and when you calculated its correlation coefficient, it would either be 0 or very close to it. Okay, it might be something like 0.2 or 0.3 or -0.2 or -0.3, but it's going to be a very small number close to 0. The correlation coefficient only assesses the strength of a linear relationship between two variables. Remember yesterday how we were talking about exponential functions, the ones that curve? We don't do correlation coefficients for those. Okay, we're only going to do the correlation coefficient for linear functions. The correlation coefficient does not assess causation. So just because you end up with a scatter plot that's very strong positive or very strong negative, that doesn't imply that there was causation. There could be, but it doesn't mean there was. Okay, now this is what I want you to do. I'm going to leave these projected. I'll flip back to them in a second, but I want you to try 14 and 15 on your own, page 14 and 15. On each of these pages, they've given you 4 graphs and 4 correlation coefficients, 4 numerical values. They want you to match the graph with the appropriate correlation coefficient. So I want you to try that by just looking at what these notes say. Alright, so the first thing I would narrow it down by is positive or negative. We see that we have 2 negative correlation coefficients, so let's look for the 2 negative graphs. Which graphs are negative? I would say B and D. Okay, C, I mean think about it. If you tried to look at it this way, it looks positive, but you're like leaving out all of those. If you go this way, it's negative, but you're leaving out all of those. So really, that's the no correlation, right? But D, you could definitely try, to do a best fit line and it would go down. Okay? So it's negative, but it's weak negative. B is also negative, but it's very strong. It's a perfect line, correct? So the more perfect it is, the closer to 1 it is, but in this case, -1. So graph B belongs to that correlation coefficient of -1. And so that means the other negative would belong to graph D. Okay, and then which graph would have belonged to a positive one? A, because it's positive and it's perfect. Okay, if it's a perfect line, it's a perfect score of 1, a correlation coefficient of 1. And then the last one would be C, no correlation at all is 0. Okay. Then page 15. Okay, same thing. First narrow it down with positive and negative. We have 2 positive correlation coefficients. Which graphs are positive? A and C. Which one is stronger? A. When it's stronger, it has to be closer to what? 1. Out of those 2 positive values, which one's closer to 1? This one. So that's graph A, so that means this has to be graph C. Okay, then between B and D, they're both negative, but which one is stronger? B, so which one is it? -0.90 is closer to -1, right? Think about it, that's only 0.10 away. So B, and so this one would be D. Okay? Alright, so now you basically kind of understand what the correlation coefficient is. Now we're going to actually find how to calculate it and find one. Okay, an education research team is interested in determining if there is a relationship between a student's vocabulary and how frequently the student reads books. The team gives 20 students a 100-question vocab test and asks students to record how many books they read in the past year. The results are in the table below. Is there a linear relationship between the number of books read and test scores? Okay, if you were asked to draw a best fit line, what direction would you go? I would definitely go up. Now, obviously, I don't hit a lot of points, and it's far away from a lot of the points, so that would be considered what? Weak positive, and that's actually going to go down here, step 4, weak positive. Pay attention. Okay, step 2, they're wanting you to describe the relationship between the data, like what's going on here, what's being compared. Okay, so aren't they asking like how number of books read affects test score? Yes, that's what they're looking at. They're looking at the number of books read and how it affects the test score. So how the number of books read affects test score. Okay, now we are going to learn how to calculate the correlation coefficient. Okay, this is no longer matching. We've got to calculate it. I'll go ahead and tell you correlation coefficient is represented with the letter R. You know, like slope is represented with the letter M. Correlation coefficient is represented with the letter R. Now this is the way you do it. Get your calculator ready. The first thing that I want to do is I want to clear our calculators and like reset them back to default settings. So the first thing I want you to press is the second button, which is that blue button. Then down here, look at the plus sign. What's above it? Mem for memory. Mem for memory, because we're trying to clear the memory. Okay, so we're wanting to reset it. So 7, and then all around 1, and then reset 2. So second plus sign 712. Second plus sign 712, and then your calculator screen should say that. Okay, now, for the calculator to do the correlation coefficient, we're going to have to turn something on. So I want everybody to go up here to mode, the button to the right of the second button. Hit mode. You're going to scroll down until you see the words Stat Diagnostics. Now, mine's already up there on my first screen, but I'm pretty sure y'all have to go on to the next page. Go until you see the word Stat Diagnostics. See how right now off is highlighted? Go over to on and hit enter. And see how now it's only highlighted on? So it's ready to go. Okay. So now that the Stat Diagnostics is on, anytime you want to get back to that main screen, look at here. See this word quit? But to use anything that's written above a button in blue, what do you have to hit first? So second, quit. Will take you out of any screen you're trying to get out of. Okay, now that we've turned on the Stat Diagnostics, we're ready to calculate the correlation coefficient. So the first thing we need to do is we need to enter all this data. How do we enter all that data? Stat, edit, and look, everybody should have L1, L2, and I think L3 is where y'all stopped. L1 is all the X values, which in this case is books read. L2 is all the Y values, which is test score. I'm not going to sit here and call all of these out. Everybody just start entering on your own. Okay, does everybody now have all the data entered? Not yet? Okay, I'll give you a few more seconds. Okay, y'all ready? Okay, once the data is entered, just like we've been doing, go back to Stat, but this time Calc. Okay, but this time you're going to use number 8, not number 4 like we've been using, number 8. Okay, it's going to give you the correlation coefficient. So hit number 8. Now, just like always, it'll pop up that your X values are in list 1, your Y values are in list 2. You go down and calculate, and look, it gives you your slope, your y-intercept, and your R, your correlation coefficient. Now, if yours popped up and it only had y equals a plus bx and a and b, and it didn't have these r's, it's because you didn't go to mode and do the Stat Diagnostics on. So is anybody missing the r's? Okay, did you go back to your data and make sure that you entered it all incorrectly? Bring it up here and I'll check it. No, 8. Go to calc and then 8 and then calculate it. Go to stats. Remember guys, I told you that correlation coefficient is represented by R, not R squared, R. So the correlation coefficient is 0.48, which makes sense. We knew that it would be positive because when we did do a line of best fit, it was going up, so positive. But remember, 1 is perfect. That's nowhere near perfect, right? 0 is no correlation at all. Isn't that kind of in between no correlation and perfect? Like when you consider that halfway in between really bad and perfect? So that's why it's 0.48, halfway in between 0 and 1. Okay, now I want you to try the next page by yourself. Try page 17. Now let me go ahead and point out something to you. Look at the board. This was a lot of data. So instead of them like continuing practice shots under here and making it a long chart, they just moved it over here. So like this is X values, but this is a continuation of the X values. This is Y values, but this is a continuation of the Y values. Okay, so make sure when you're typing it in, all of that and all of that goes in L1, and then all of that and all of that goes in L2. Okay, so a hockey coach wants to determine if players who take many practice shots during practice have a higher shooting percentage. The shooting percentage is calculated by dividing the number of goals scored by the number of shots taken. The coach records the number of practice shots 20 players take each practice and compares the number with each player's shooting percentage over the season. Is there a linear relationship between the number of practice shots and shooting percentage? Alright, I don't know a lot about hockey, but like if you're talking about a sport like basketball, don't you think the players who are down in the gym every day practicing, like shooting over it again, over and over again, are going to be the players who make more points during the game? Yes, so it makes sense to me that with this type of scenario, the graph would be strong positive. Because there's definitely a strong positive correlation between those two things. How many practice shots and how it affects the shooting percentage. Okay, hold on. Okay, it makes perfect sense to me that that data ends up being strong positive. Okay, now, before you even calculated the correlation coefficient in your calculator, just by looking at the data, you know your correlation is strong, so you know it's positive. So you know it's a positive value, and you know it's close to positive 1. But what did you get? 0.94. All they're asking you to do is write down in words what kind of correlation it has. Strong positive. Okay, and the reason that it was 0.94 is because it's strong positive. Remember, the strongest you can get is 1. That would be a perfect line. Okay, every point would have the same slope all the way up. This one obviously wasn't a perfect, but pretty strong, so that's why it's a number close to 1. Okay, now in the next page, you got a little more work to do. You have to do the scatter plot yourself and then answer the question. So take a few minutes to do that. Okay, so your scatter plot may look a little bit different than mine depending on how you numbered it, but everybody should be what kind of correlation? Strong negative. Yeah, as you go, as your classes get bigger, the scores are getting worse. Okay, so we are comparing how class size and your correlation coefficient will verify that affects average test score. When you put the data in your calculator, what was the correlation coefficient? Negative 0.84. Okay, look, negative. Oh, you typed this in the wrong then. Negative 0.84, which makes sense because it's definitely negative, and I mean it's not the strongest, but isn't it pretty strong? And isn't that number pretty close to -1? Okay, this is your homework. Okay, pay attention. Page 19, which you can do now in less than a minute, is so easy. Page 20 and page 21. It's just one problem on each page, just like we've been doing today. On page 22 is where you'll find the graphs for those two problems. Now, I am aware that you do not have a graphing calculator at home, most of you anyway. But you know enough now to at least plot the scatter point, talk about the data, and guess the R value. Okay, you can make an educated guess. You know whether it's positive or negative, and you know how close to 1 it should be. So just make a guess, and then tomorrow we'll actually calculate it and see how close your guess was. I will be checking it, so make sure you do all of those pages, 19 through 22.